In the following example, we have MA is greater than MB, so this is the heavier mass, and both the masses start at some height h above the floor. So we're starting like so, or actually, why don't we just label it as this? So this is some height h. And then what is the final speed of the blocks when block A hits the floor? So so this is the initial starting point of the system. When this block moves downward and is about to hit the floor, so here's block A, well, block B has moved upward some height h. So while this block has moved down h, this block has moved upwards h from this point. So this height is some h, and here's block B. So let's compare the total energy initial, E initial to E final. So initially the system is released from rest. So we just have the potential energy of block A initial plus the potential energy of block B initial. There's no kinetic energy. And then in the final point, we have block A is moving downward with some V, and block B is moving upward with some V. We'll call it V final. And since they are attached via this pulley, and they're attached via the springs, via this rope over this pulley, they're moving together with the same velocity. So in the final point, we have, well, block A, since it is about to hit the ground, and this is y equals 0, it doesn't have any potential energy, we just have kinetic energy final. But block B is both moving and it's off the ground, so it's going to have both potential energy and kinetic energy in its final state. So first, let's write the kinetic energy of block A, which is 1/2 MAV final squared. Then let's write the kinetic energy of block B, which is 1/2 MBV final squared, plus the potential energy of block B, which is mg2h, because it's now twice the height off the ground. All right. So now, on the left-hand side, we need to plug in the potential energies. So that's MAGH plus MBGH, and that's equal to what we just wrote down. So let's just copy this. All right, now we need to do some algebra and simplify things. So on the left-hand side, I'm going to factor out a GH. So I have MA plus MB. Actually, it might be more useful to leave these separately, because the first thing I'm actually going to do is subtract 2MB GH from both sides. So subtract 2MB GH from both sides. And that leaves us with MAGH minus MBGH. On the right-hand side, I'll go ahead and factor out a V final squared from both of these terms, which leaves us with let's factor out a 1/2 V final squared. So we have a 1/2 MA plus MB V final squared. And then I'll go ahead and multiply both sides by 2, so cancel the half, multiply by 2. So getting VF by itself is the square root of, this is our numerator, divided by this factor is our denominator. So 2 GH MA minus MB divided by MA plus MB. Now, doing problems like this where you are given symbols for all the masses and the height in this case, and then symbolically solving for the final velocity is going to be more and more common. So getting used to doing algebra like this is important, so make sure you practice this on your own.